Hello scholars, welcome back. Mr. Hinkle here. I am so excited to talk about Half Dome. Hooray! No, not just Half Dome, but the geology of Yosemite. Yosemite, one of the great wonders of the world. California's claim to fame for having such majestic beauty of the landscape right here in our beloved Sierra Nevadas. And there is so much that we could say about Yosemite, from its rich history to current tourism to things to do and explore. But what I want to do in this lecture is discuss the geologic history through the lens of earth science for why is this even there? So that is what you and I are going to do right now. We'll identify how Yosemite formed by geologic processes. We will look at the rocks. We'll analyze the various rock types present in Yosemite. There's no discussing the geology of Yosemite without discussing the role of glaciers in carving Yosemite Valley, and we will highlight geologic features and processes that are happening in the valley in Yosemite right now. So, little intro. Yosemite, it's awesome. It is in the Sierra Nevadas, the great big granite batholith that extends half the length of California, trending northwest, southeast. It is a large fault block mountain range, the biggest fault block mountain range in the United States, and Yosemite is California's most famous national park. In fact, it's known for its majestic landscape, beauty, grandeur, and every year the park sees about 3.5 million visitors, including me. I've been to Yosemite once already this year, looking to get out there again. Are you one of those 3.5 million? If not, let's go right now. Hopefully this lecture, this discussion will inspire you to want to hop in your car, drive to Yosemite, and see this for yourself with a little bit of understanding about what is happening, geologically speaking. So let's talk about the formation, and we can't talk about the geology without talking about geologic processes. So, two big concepts in earth science. The raw materials of earth are minerals and rocks, and they are created, transformed, and destroyed within this phenomenon we call the rock cycle. Another huge topic is plate tectonics, which states that the surface of the earth is covered by large, rigid bodies of rock, and they move over the surface. Where they meet are plate tectonic boundaries. There's three types. Where two tectonic plates meet and are moving towards each other is called a convergent tectonic boundary. Now, this was happening way back in Earth's history. So we've got 100 million years ago, give or take, subduction of oceanic crust underneath of continental crust. This is a basic lesson in plate tectonics. See my lectures over there if you're interested. And what happens when one plate subducts underneath another is this is usually at the bottom of the ocean, underwater. That water is incorporated into the rocks, and when you take that rock to depth, the interaction of the depth and the heat, the pressure, and the water creates a process known as flux melting, which causes magma to generate. It melts the rock. That melted rock is less dense than the surrounding rocks, and it creates what are known as plutons, large bodies of plutonic rock, thus the pluton, and we'll see some plutons in my next slide, at depth. So these are all plutons. In the process, these plutons are really, really hot. And that heat changes some of the surrounding rocks. It changes their mineralogy, and it changes their texture. And so what we get are metamorphic rocks. So, geology is happening. This is happening currently in many places around the world. The Cascade Range in northwestern United States, the Andes in South America, active tectonics. So here's our little lecture on the emplacement of granitic rocks in subduction zone, metamorphism of older sedimentary rocks. This is what we've shown. Emplacement of plutons, metamorphism of older sedimentary rocks, because there was rocks that were there already. Okay, what's next? Uplift and erosion to expose plutonic rocks. So things are happening, time goes on. This plate completely subducted. There is, okay, I'm doing millions of years of geology. So now we have the Coast Range, we have the Central Valley, the San Joaquin Valley, and we have uplift and erosion of the rocks that were once inside the heart of the mountains. They were in the belly of the beast, and then erosion comes in. That's all gone. Doot, 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 doot. Now these are all gone. Okay. Excellent. So all that material, where did it go? It was weathered, eroded, transported, and deposited. A lot of it in the Central Valley, which created the lush, fertile soil that we have today. But let's continue with how did we get geology? So the geology of Yosemite. So here we have lots of granite, a little bit of metamorphic rocks. You have a stream-cut valley that's wedged into a V. Uplift and erosion expose these plutonic rocks, which we see, and then you have glaciation, extensive glaciation over the course of the last 3 million years that came out and carved Yosemite Valley into its current U shape. I'm going to talk about more of that in a little bit, but basically it said, well, let's use green again. Green's going good. It said chunk, like so, and now we have Yosemite Valley. Okay, so quick little rundown how Yosemite formed. Granite formed inside of the earth. Then there was uplift and erosion that exposed the granite. Then glaciers carved Yosemite Valley into the prominent features that we see today. Geology, geology, geology. It's all geologic processes. But in a nutshell, this is the geologic history of Yosemite. Okay, let's keep going. So we've got various types of rocks. Look at all these squiggles in these rocks. That's pretty cool. These are metamorphic rocks with a Brunton compass for scale. Look at all these large interlocking crystals that look like puzzle pieces. This is igneous rock. There's a penny for scale. So if we go down the line, these metamorphic rocks began as sedimentary rocks dating to about 400 to 500 million years old. They were metamorphosed into quartzite and marble. They're the oldest rocks in the park. There's not a lot of them, but they can be found in various places. And the dominant rock type of Yosemite is granite. About 90% of Yosemite's rocks are made of granite, which we see here in the upper slide. Granite is composed of the minerals quartz, K, feldspar, plagioclase, feldspar, biotite, and hornblende. Now, we identify and classify igneous rocks based on texture and composition. The texture is coarse grained, and the composition is going to be the various makeups of the minerals. In certain percentages we get granite, but in varying other percentages we get granodiorite, diorite, and tonalite, all present in Yosemite National Park. Now, we have more recent episodes of volcanic lava flows 30,000 to 650 years ago, which give us exposures of igneous extrusive rocks, basalt, and andesite in various places of the park. So that would be like, now we've got magma chamber coming up, doot, 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 and a lava flow. Okay, so what does Yosemite have? It has igneous rocks and metamorphic rocks. There are also lots of sediments from the processes of weathering and erosion, but they have not turned into or transformed into sedimentary rocks. That would take a lot longer, and Yosemite hasn't had the time to do that. So, plate tectonics created the granite and the metamorphic and the volcanic rocks. Then, Earth's surface processes, glaciers, carved Yosemite Valley. And it goes a little bit like this. Here we can see the Yosemite Valley cut by rivers. Now I'm going to do this all over again so you can see. Yosemite Valley cut by a river. So the Merced River, which runs through the middle of Yosemite Valley, cuts straight through, forming a V shape. Well, this whole valley got filled with glaciers, as you can see here. There's Half Dome peeking out. You can see a little bit of El Capitan. And what happened was, as the glacier filled up this valley, it eroded a lot of sediment. It scraped the landscape, changing the shape of it. And when the glaciers receded, what was left behind was a deep U-shaped valley. So the glaciers came in and essentially were up to this level. They moved through the process of glacial advance, eroding all of this material. Awesome. Okay, goodbye material. Leaving behind a nice wide U shape. And U shapes are characteristic of glacially carved valleys. Well, the material that was coming from the glaciers and some of the tributaries came in and deposited in the middle of the valley, forming a nice thick alluvium, which the Merced River has the opportunity now to migrate back and forth across. And it has these tortuous meanders as it bends from one side to the other, and it bends from one side back to the other and over again. Amazing. So why does Yosemite have such a wide, big, open valley that's super flat with sheer, steep cliffs that extend high into the sky? Well, plate tectonics and the formation of the rocks, and Earth's surface processes, glacial erosion, carving the prominent features that we see. And one of these big, okay, let's look at a map. Why don't we? Great idea. Let's look at a map. So here's the Sierra Nevadas. Here is the Tuolumne River, Tuolumne Meadows, and the Tioga glaciation. So this was the extent of glaciation in, what do I have here? The last 26,000 to 18,000 years ago. And this is because climate changes. Climate changes naturally. There are periods of cooler temperatures and periods of warmer temperatures. And the paleoclimate record indicates that higher temperatures are associated with increased concentrations of carbon dioxide in the atmosphere. And when you have lower concentrations of CO2, temperatures drop. So it is no surprise to scientists, to climatologists, that through the burning of fossil fuels and the increased amount of CO2 in the atmosphere, we also have increased global temperatures. The Earth has seen it before, it'll see it again. So, glacial extent in Yosemite, you can see the Sierra Nevadas at high elevations are a glacially carved landscape. And what comes with these glacial processes are glacial landforms. Cirques, big bowls in the mountains, tarns, lakes that fill those bowls. Hanging valleys, which are the waterfalls of Yosemite. Now, these features are one of the main reasons I like to go to Yosemite, to watch these amazing waterfalls, especially in the springtime. It's so cool to watch water fall from such high distances. Here we've got the beauty of upper and lower Yosemite Falls, the grandeur of Nevada Falls. There's also Bridal Veil, Vernal, Horsetail. There's so many waterfalls, but these are the big ones. And we could think of it a little bit like this. So remember, let's bring this back. When Yosemite was a V, and the Merced River was right here in the middle. Well, there was tributaries. What happened to the blue pen? Got it. There was tributaries that were coming into that river. Okay, great. So here's a river now. It's got its own, let's try and do a little bit of 3D. It's got its own V-shaped valley. And the river's traveling down all the way to meet the Merced River. But now, let's carve out this valley and say, once again, here's the alluvium in the bottom, the Merced River. Well, what's this river to do now? The tributary to the trunk stream now has been punctuated through the glacial erosion, and all of a sudden it's falling down that steep side to now meet its friend, the Merced River. And this is what we see. A glacially carved valley of Yosemite, and one of the artifacts of that are hanging valleys where we have these huge waterfalls that plummet thousands of feet, artifacts of glacial erosion. So, if you're asking yourself, why does Yosemite have so many beautiful waterfalls, which is a good question, the answer would be because Yosemite has been carved by glaciers. If you are in Yosemite, what you got to watch out for, the active tectonics that are happening, is rockfall. Here we can see all of these clouds are coming up because there was rocks that fell from the side. Erosion is a natural process, and rocks erode through the processes of weathering that breaks down rocks. On these sheer cliffs, when the rocks dislodge, they detach from the basement, from the bedrock, they move rapidly downslope, and they form in large piles at the base of these steep slopes called talus piles or rock debris. Very hazardous. This is a building that was destroyed. This is a very large tree that was completely knocked over. The tent cabin in Curry Village have been wiped out. Rockfall, it's maybe not the biggest hazard in Yosemite, but it does cause fatalities every single year. So it's something to be tuned in and cognizant about. And there are lots of great individuals in the park who are studying the geology and know the rocks very well in order to mitigate any of the hazards associated with rockfalls. But looking back at the rock records for over 150 years, there's been 1,000 rockfalls, so they're not stopping anytime soon. Yosemite is in a very active landscape, so if you hear the rumblings on the side of the mountain, make sure you look up, look around, and get out of harm's way if those rocks are coming towards you. Okay. This is the view. Driving in Highway 41, you make your way through the tunnel, stop at the parking lot, and boom! There it is, tunnel view. You can see, let's see, we've got El Capitan over here on your left, Bridal Veil Falls on your right. Here's Half Dome. Look at this nice big sweeping U. Evidence of glaciation. There's more than just the shape of it, but this is one big giveaway. And look at this big sweeping U with the waterfall. This is a hanging valley. Very, very exemplary of Yosemite. Isn't this beautiful? And when you go to Yosemite, it never gets old. It doesn't get old. I've never lived there, but I wonder if you live there, if you still feel that way every day. You're like, wow, this is amazing. So let's summarize. Yosemite National Park is created by geology, and the geology, the rocks in the landscape are how we know what's happened in the geologic past. Yosemite gives us an understanding for the formation of California, for the formation of the Sierra Nevadas, and it's a really beautiful place to study California geology. And the rocks, as I mentioned, they provide information on everything that I've taught here, how the granite formed, the glacial geomorphology, and the plate tectonics that is associated with creating the various rocks that we see. So I hope that you learned a little something about Yosemite. I hope you are inspired to take your next visit or your first visit to Yosemite National Park, and that you can enjoy Yosemite in all of its natural wonder, beauty, and geology. Thank you so much. I'll see you again.